I'm Tonja Heinemann from the University Stuttgart. I've got a research project with news at the Innovation Campus Mobility of the Future. That's a project of the University of Stuttgart and Karlsruhe. So I'm with the UMATI team. I'm also at the booth in Hall 9. And what we do there, what we have in terms of vision, we've got machines cooperating and communicating via OPC UA. And these machines communicate the same data that fit. A robot always communicates the same identical data, no matter what manufacturer they're from. So vis-a-vis the status of today, I have the advantage that I know what communication options I have and what possibilities there are. At the moment, different machines of different manufacturers with different controls usually use very different protocols, and it's very difficult to link them up with each other because you have to develop something for each and every machine, and we want to get away from that. Now, I said OPC UA, but what is that actually? OPC UA is a standard for communication in the machine tool sector, and it comprises everything that has to do with communication. So it starts at the bottom with communication protocols, everything that happens on the wire with encoding and transport. Then there's a communication model. At OPC UA, there's a client-server model with a server that provides functionalities and a client that calls up these, or a publish-subscribe model with a publisher that provides information and updates them or provides them all the same, and subscribers who select information from this stream of information. And there are different types of encoding and transport because technically different things are suitable. And the next question that I need to look at if I want to transfer data, what am I actually trying to map? What am I talking about? For this, OPC UA has the rule of how this works. That's the meta model. And with the rules of the meta model, it's got the communication or the information of what's being transferred and transmitted. So for different sectors, what do I want to transfer to the robots, the robot experts, or what do I transfer to the machine tool? Then the machine tool experts will know this, and then these companion specifications are compiled. This is where UMATI is placed. These companion specifications are done by the UMATI team, and they communicate about this amongst each other. And if the things in the companion specifications are not enough, then they can be supplemented with proprietary specifications that you see at the top of this model. So you've got lots of options, but I know them all. That's the protocol bindings, and at the top it's the companion specifications. Now, we not only have machine and robot manufacturers who want to participate in standardization, but there are also people who we'd like to use the data. We would like to have a status overview or calculate KPIs, and I assume that many users here have same or similar use cases. I assume that many companies would like to have an overview of all their machines in production or would like to do KPI calculation for their quarterly figures. And for this, from the machines that you have to collect the data. Then for the status overview, you simply have to show them for the calculation of KPIs. Then these have got to be calculated, first of all. And I mentioned that there are different options for this. So this is the detailed overview of what this actually looks like. So you've got the 7 OSI ISO layers, and depending on the application, you can use whatever's suitable. For instance, when it comes to the encodings, OPC UA binary is suitable, especially if you have smaller devices with low calculating performance, or when it comes to JSON coding, it would be enough if you had the calculation power and enough space on the wire. But if for certain applications, OPC UA is very flexible, which means that if you want to implement it, you have to know what it is using, because it may differ between different machines that all use OPC UA. And on the other side, it's rather similar. The OEE calculation, it's usually calculated from availability multiplied by performance multiplied by quality index. And all these have an individual calculation. And I looked at availability only. So you would get live data from UMATI specifications, the actual production time, for instance. The planned production time is something that you wouldn't get usually, because in the specifications so far, we used to say, well, the machine doesn't have to know what the plan was, but it's telling me what it actually did, how much time it used. This is a screenshot from the UMATI dashboard. If you want further information on this, then you can come and visit me in Hall 9 or ask me after the presentation. So there's one robot and one machine tool that I picked out. And as you see, there are a few details, and the headings show you that they link up to different data because a robot is not a machine tool. For the OEE calculation, this means if you've got the actual production time from a machine tool that you want, you need a date that's called item state. In the state is executing, and one is called operation mode, and you want this to be processing. But if you don't have a machine tool but a robot and calculate the OEE for that, then you've got a value called execution mode, and it's got to be in cycle or continuous. This is the knowledge that I need to have to start with. So for my project, I've got the challenge to think about the use cases that I will need. Is it really the monitoring, the OEE calculation, or is it other use cases that I'm looking at? Are they as general as assumed? In the simplest case, the OEE formulas could be done with the data from the specifications, and for companies that didn't have anything at all, this would be quite something to start with. And it would be easy to bring them to a common denominator, to adjust them a little bit, to adapt them when it comes to OEE. Of course, you want your own operational processes reflected. Now, for all this to work automatically, you've got to have the overview of all the communication forms in OPC UA. You have to automatically detect them and use the summary. And then you need to have an overview of the different companion specifications in order to be able to say, for the value in the OEE calculation, I need this and that value from the specification for machine tools, or specification for robots, this other value. And with adjustments for different use cases, I want to be able to use all this and expand on it. So if you wanted to have this today, I would think about what I would want. This would be the starting point. Then I'd look at the production, or the machines would be connected and linked up. Of course, assuming that they all have the same standard. And then I would select the data on every machine that I would need and would write the app that evaluates them. That's the box saying OPC UA client server data models. At the moment, all this would have to be done manually or pay for someone to do it manually. And what I would like to have is that the user would have to think about what he or she would like as added value, and that I provide software that would do all the further steps, that would look into the network, find all the machines. They would support that. This is a functionality that OPC UA already has. And the companion specifications would also be familiar because they've already been published. You can look at a database to get them. And then to also know how the data from the companion specifications would have to be linked up with the use cases. And that would then compile the software accordingly. And what this software would look like is this. There are some blocks. I would like to have an OPC UA client or subscriber who can receive the data, and which data is actually used is familiar from a use case, libraries, so that you know what you need, that you do the configuring a configuration. It says low-code configuration here so that you don't have the complicated programming, but you can do it rather simply with configuration options that you have at your disposal. And then, so that would be the OEE calculation, by the way. And that for every companion specification, you would have the data OEE value A in companion specifications for machine tools. It's got this. OEE value A for robots is something else. And once I combine these things, because the user would select one of the purple ones for the OPC UA client, the software would find automatically what it needs and which companion specifications would be taken from the library, all the use cases that it needs. It would be put together as a puzzle and would then generate. That's the vision that I have. Within this project, I'm also doing something for Umati. This is a chart that you can see at our booth. And where I come in is where the plug-and-play idea starts. So the configuration software would be connected, and it would configure the steps automatically, and then it would generate a tool that I could work with. And just as the showcase that we're showing here, which is a monitoring interface, it would be one example of how to use Umati data in a sensible way. We would also contribute to lessons learned. We would also probably issue best practices and use best practices from the Umati community, and feedback from users would also come in. So if I were to note anything in use cases, then I could feed this back into the standardization process. The two lower points don't really affect my project at all. The international appeal of Umati isn't really affected, and an agreement of identical implementation refers to the server, the data providers, and I'm not looking at them. I'm just assuming they're there. And I'm not on my own here. So at the University of Stuttgart, there's an Institute for Software Quality, and other companies are participating. Some pragmatic industries have certain platforms. The FVA software and service knows a lot about OPC UA and the companion specifications, and the Precogit company has an MES system implementing data and doing all that. And I'm very glad that they're all contributing to the project. And I'm also very happy that you've all listened attentively, and if you have any questions, then fire away.